Okay, theorem 2.5. Okay, okay, okay. In total, there are n objects, but this n object can be classified into subgroup, n1 group, n2 group, and to nk group. But in each group, we see all the element within the same group is the same. So even though okay means that the arrangement is not important. For this case, how many way for us to arrange that? You look at example 2.21. In the college football training sections, the defensive coordinator needs to have 10 players standing in a row. Among these 10, there are one freshman, two sophomores, I don't know what is it, four juniors, and three seniors. So if you look at, like for example, four juniors, you just know that they are junior. Four of them are junior, but they look alike to you. You cannot arrange, you cannot differentiate them. So now you want these 10 persons stand in a row, side by side, okay, and how many way you can arrange them. So if you can recognize 10%, you don't care about this. You say, oh, this is Ali, this is Abu, this is Akau, and so on, 10%. Then the answer is 10 factorial. But because of they are in the same group, they wearing the same T-shirt colors, you just recognize with colors. So that's why the way is different. It's much smaller. So that's why the answer is okay 10 factorial divided by 1 factorial, 2 factorial, 4 factorial, 3 factorial. So wherever value factorial value divided in at the bottom is you want to discount them their arrangement. So that's why the answer is 12600. Maybe okay we go to these examples. 2.24 statistics. So I want you to arrange them in different orders. I don't care whether it's readable or not readable. I just want. So you can see clearly there are 3T, 3S, 2I, and the rest is 1 and 1. So now how many ways for to arrange them? So even I change the position of T, for example, you cannot recognize them inside. The place is different. So that's why arrangements within the same group okay is not important. So that's why you want to discount them. So when you discount them, they are not for 10 factorial anymore. They become okay equal to 50,400 ways for you to arrange these word statistics. In how many ways can seven motor cars, sorry, assigned to one triple and one and two double rows? So imagine that these seven motor cars has no plate numbers. If you have plate numbers, then the answer is 7 factorial. But because of they are not in the they don't have the split numbers, you just divide them into one group with three, then two group has only two. So how many ways for you to arrange them? So the answer is equal to 210. Okay, in short, okay, this is what we call the NCR. So NCR, the equations, it will look similar to NPR, but except, okay, the R, you add R factorial down here. Why you add R factorial down here? Because of you cannot recognize either you select the case you selected them or the case you didn't select them. So this is what we call combinations. Okay, example 2.33. A boy asks his mother to get 5 Game Boy cartridges from his collection of 10 arcades, 5 sport game. How many ways are there his mother will get 3 arcade and 2 sport game respectively? So because of okay, there you want okay like now you want to uh, get 10, you want to get 3, 10 arcade you want to get 3, then the answer is NCR. So it's equal to 10 factorials. Okay, 3 factorials, we divide by 3 factorial, 7 factorial. 3 factorial is, even though the 3 you selected, the arrangement is important. It's not that important. And 7 is not selected, then it is also already not important. So that's why the answer is 130. The same explanation for sport games. So we have 5, we want to choose 2. So the answer is equal to 10. So because of we want to get 5 of these two groups, we want to get 5. That's why it's using the multiplication rule. So the answer, how many way? There are 120 way multiplied with 10 equal to 1002. So when we multiply in this case, you can use the concept of probability tree for you to mention why must we multiply them. Okay, then we have tutorials tools.